Good evening. I'd like to talk about solve the quadratic equations of the form x squared equal to k using the square root property. Let's first understand what's the meaning of the square root property. If we have a quadratic or a simple quadratic equation of the form x squared equal to k and k is greater than or equal to 0, then we have two solutions for x. The first one is x is equal to positive root square of k, and the other solution for x is equal to minus root squared of k. I'll talk about these 5 examples. The first one is x squared equal to 16, x squared minus 9 equal to 0, 4m squared equal to 36, n plus 5 all squared equal to 32, and 8d minus 6 squared plus 24 is equal to 0. Let's start with the easiest quadratic equations, which is the x squared equal to 16. So we need to solve for this equation using the square root property. See that the equation is in its correct form, which is the x squared equal to k. So now we can use the square root property. So the solution for x is plus or minus root square of 16. Now simply we can simplify the radical. So the root squared of 16 is 4. So we have two solutions for x. The first is plus 4 and the second is minus 4. We can simply check for our two solutions. For the first one, which is x equal to plus 4, so x squared is equal to 4 squared, and 4 squared is equal to 16. So it is same as the original quadratic equation. So our first solution is correct. Let's check for the second solution, which is x equal to minus 4. So x squared equal to minus 4 squared, and minus 4 squared is equal to 16. Again, it is the same as what we have in the right side of the quadratic equation, x squared equal to 16. So our two solutions are completely correct. Let's solve x squared minus 9 equal to 0 using the square root property. If you see here, the equation is not in its standard form. So the value of x squared should be in one side and the constant should be in the right side. So simply we can add plus 9 to both sides of this equation. So the equation becomes x squared equal to plus 9. Now we can simply, as before, use the square root property. So x is equal to plus minus root squared of 9, and root squared of 9 is simply 3. So our two solutions for x is equal to plus 3 and x is equal to minus 3. Now we can simply check for the first solution, which is x equal to positive 3. So x squared minus 9 is equal to 3 squared minus 9, and 3 squared is 9, 9 minus 9 is 0. So it's same as the original quadratic equation. So our first solution is correct. Let's check for the second solution for x equal to minus 3. So again, x squared minus 9, it's equal to minus 3 squared minus 9, and 9 minus 9 is equal to 0. So the second solution also is correct. Now solve for m squared. equal to 36 using the square root property. See that the coefficient of m squared is not 1, it is 4. So simply we can divide both sides of the equation by 4. So 4m squared divided by 4 is simply equal to 36 divided by 4. Now we can simplify. So 4 cancel with 4, and 36 divided by 4 is equal to 9. So we have this new quadratic equation, m squared equal to 9. So now simply we can use the square root property. So m is equal to plus minus root square of 9. So we have two solutions for m. One is positive 3 and the second is minus 3. Now we can check for the first solution, which is m equal to positive 3. So this is the original quadratic equation. So for the first solution, 4m squared, 4 multiplied by 3 squared, it's equal to 4 multiplied by 9, and 4 multiplied by 9 is 36. It is same as the original equation here. So our first solution is correct. Let's check for the second solution, which is m equal to minus 3. Again, 4m squared is equal to 4 multiplied by minus 3 squared. So 4 multiplied by 9, again it is 36. So the second solution is correct. Let's solve n plus 5 all squared equal to 32 using the square root property. See that instead of one variable squared in the left side, we have a binomial which is n plus 5 all squared equal to 32. We deal with this binomial same as one variable. So if we use the square root property for both sides, so n plus 5 is equal plus or minus root square of 32. And the root squared of 32 is simply, it is 16 multiplied by 2. So now we can take the 16 under the radical outside. So n plus 5 is equal plus minus 4 multiplied by root squared of 2. So we have here two solutions for n. So the first solution, we can use the plus sign here. And if we add minus 5 to both sides, so n is equal to minus 5 plus 4 root square of 2. This is the first solution. And for the second solution, we can use the negative solution of the radical. So n is equal to minus 5 minus 4 root square of 2. So this is the second solution. Simply we can check for the first solution, which is n equal to minus 5 plus 4 times root squared of 2. So n plus 5. This is the value of n. And this is the plus 5 all squared. If you see here, minus 5 cancel with plus 5. So the remaining inside the parentheses is 4 times root squared of 2 all squared. So 4 squared is 16 and root square of 2 is 2. So 16 times 2 is equal to 32. So it's same as the original quadratic equation. So the first solution is completely correct. Regarding the second solution, I will leave it to you. Finally, let's solve 8d minus 6 all squared plus 24 equal to 0 using the square root property. First of all, we have the binomial squared in the left side and also the constant in the left side. So simply we can separate by adding minus 24. So by adding minus 24, we get 8d minus 6 all squared equal to minus 24. Now we can use the square root property. So 8d minus 6 is equal to plus minus root squared of minus 24. So as you know, root squared of minus 24 is not a real number. So there is no real solution for this quadratic equation. That's all about solving the quadratic equation of the form x squared equal to k by using the square root property. Thanks a lot. Goodbye.